Alright, let's take a look at question 11. And this problem, we're going to be looking at how to evaluate an expression using two or more expressions. Alright, so it reads, if c equals 2a squared minus 5 and d equals 3 minus a, then the expression c minus 2d equals. So let's go ahead and start by specifying what c and d are. So in this problem, c is 2a squared minus 5, and d is 3 minus a. Okay? And then we have to evaluate this formula expression c minus 2d using these two pieces of information. Now all we're simply going to do here is we're going to take the c value, which is 2a squared minus 5, and we're going to substitute it for c in this expression. And then we're going to take the d value, which is 3 minus a, and substitute it for d in this expression right here, and then evaluate. Alright, so something to keep in mind, a tip for the Regents exam, and this tip is concerning substitution in parentheses. What's the tip? The tip is as follows. You always want to use parentheses, so always use parentheses when substituting. Okay? The reason why you want to always use parentheses when substituting is it helps you avoid making errors associated with sign and exponentiation. Okay? Alright, and another word of caution, something that you really want to keep in mind, caution, this has to do with having negative in front of parentheses. Okay, so you want to watch out for the negative sign in front of parentheses. With expressions inside. The reason being that signs change whenever you have a minus in front of a parenthesis. I'm going to illustrate that to you right now. Okay, so we're going to start out by taking out these two variables c and d. We're going to replace them with parentheses. Okay, so in place of c, I'll put parentheses minus 2 times parentheses. Now I was going to go in the first parenthesis. I took c out. I'm going to substitute this expression right here for c, which is 2a squared minus 5. This parenthesis doesn't have any minus in front of it, so this caution that I indicated here doesn't apply. For d, though, we're going to substitute 3 minus a. But notice we have a minus in front of this parenthesis, so you always want to watch out for those because you want to make sure that that sign is distributed. Okay? So 2a squared minus 5, you can imagine as though there is an invisible coefficient here, which is just 1. So when you distribute that positive 1 across these two terms, nothing happens. So it just remains 2a squared minus 5. Now on the right side, we are not just distributing the 2, we're distributing negative 2. Okay? So negative 2 will be distributed to positive 3 and negative a. And as indicated earlier, when you distribute to negatives, signs do change. Okay? So negative 2 times 3 will give us negative 6, and then negative 2 times negative a will give us positive 2a. Alright? Now we're going to combine like terms. We'll drop down any term without any like terms to be combined with, starting with the highest degree term. The highest degree term here is 2a squared. The degree of this term is 2. So it's 2a squared. There's nothing to be combined with that. 2a, the first degree term, has nothing to be combined with, so we just bring it down. The constants, also known as your 0 degree terms, there are two of them that can be combined. So minus 5, minus 6, the signs are different, so what are we going to do? If the signs are different, is simply going to add the numbers and keep the sign. Okay, so it remains negative. 5 plus 6 is 11. So your answer is 2a squared plus 2a minus 11. Answer to this problem when evaluating expressions with expressions is option, let's see, option number, see, 2a squared plus 2a minus 11, option number 3.